Welcome to the E4S BoF at the ECP Annual Meeting. My name is Samir Shende. I'm from the University of Oregon. And here's the agenda for the BoF. Mike, I'll stop sharing.
Yeah, thanks, Samir. I will start sharing here. All right. Do you see the right version or do I need to swap?
Swap, please.
Yep. How about now?
Yeah, perfect.
All right, very good. Welcome everyone to the session on E4S Birds of a Feather. So just a few procedural things. So we have prepared materials, but we welcome questions and comments at any time. Please use Zoom chat for questions and comments, anytime through the conversation. If you want to ask or a question or make a verbal comment, just, raise your hand in Zoom. We'll try to look for those. And then maybe when there's a moment to pause, you can certainly, then we'll ask people to ask in person. If we have a small enough group, it looks like we have, roughly around 30, and you're comfortable, you probably can just speak up as well as we go along. We want to be this to be as informal as possible. So I want to give just a little bit of an overview of E4S. If you've been to other sessions, some of this may be a bit of a repeat. But I wanted to in particular address some of the core questions I think E4S is addressing. First and foremost, E4S is addressing very specific needs of the exascale computing project. We have to deliver GPU, in particular GPU capabilities in roughly 70 products to the, support the exascale computing platforms and the applications that run on those. And we need to do this in a way that is coordinated. And E4S is the vehicle that we're using for coordinated delivery of capabilities to the applications, to the facilities. We're also hearing as a part of that people need documentation and that we need to make a commitment to quality. And so you hear about all of those things as a part of today's BoF session. Furthermore, just in terms of good design and architecture and implementation, we want to build on and leverage and extend existing capabilities and activities. SPAC was available before E4S started. It was clear it was going to be a thing for HPC software. Containers and cloud platforms have been around for a while and continue to show growing impact in the ecosystem. And then, as part of sustaining the efforts that we have within ECP, we need to provide integration pathways, from source, of course, for things like math libraries, which are often installed by users or by facilities on behalf of users, but also integration into the LLVM stack, the vendor stacks, the facility stacks. That's an all an important part of what E4S activities are supporting. And then finally, how can we become, with E4S, a sustainable, open, and collaborative software ecosystem? And here it's not just about DOE, but it's other US agencies, industry, and international partners. And delivering, on the value proposition that this ecosystem that we're working on is more valuable, clearly more valuable than each app managing its own set of subset of dependencies that are part of E4S. We need to make it clear to application user teams that in building on top of E4S is worth their time and effort because it buys them something versus doing it on their own. Just to give you a little sense, these are 5 ECP application areas, and I'm not going to go into them in detail, but just to give you a sense of how ST products are used. these are the same 5 apps, Access Guide, WDM app, and so on, and their uses. This is a coding that of their dependencies, and then it shows that multiple apps have dependencies on the same product, and so the value of the software reusable software ecosystem is the fact that it's reusable, and many teams can benefit from these tools. And these are just a few instances that show that. These colors also show our efforts in what we call software development kits, or SDKs. SDKs are groupings of similar products where there's they provide similar and complementary services, and we are building communities within these areas so that people can share best practices, can benefit from each other's work, and be collaborative and complementary in their efforts. And we think that overall provides a lot of value to the development community and to the users, stakeholders that benefit from these teams interacting more with each other. All of this then is built underneath E4S. Now, E4S builds a lot of stuff that's not part of SDKs right now. This effort's led by Samir Shendi. But over time, we are integrating more of the products that we have into the SDKs, so that you have at one level the individual products, then the SDKs, then E4S. And this is in a diagram that tries to show that. The lowest level is what DOE and many other people have been doing for decades. Individual product teams are creating new capabilities, providing them to their users. That's not brand new. That's part of what DOE has done for many years for HPC. What is relatively new are these SDKs. And then what is even newer than that is E4S. And that's why we're here. And that's what this BoF is all about, is to try to engage with the community, tell you a bit about it, and also get your input on to where we should go as we go forward in the future. So where we are right now is we have a collection of community policies you're going to hear about. We have a doc portal that you're going to hear about, portfolio testing, this curated collection, committing to quarterly releases, build caches that greatly improve rebuild times, and then increasingly this turnkey stack that allows people to build on top of it and see better, faster, and cheaper as part of it. E4s.io is the main website. We're very excited to be starting up strategy discussions around E4S, building a strategic plan, engaging with US agencies, industry, and international partners. This is just a summary of what E4S is not and what it is. If you've been around E4S, you've seen this slide before, so I won't spend a lot of time on it. But the general theme of E4S is it's not meant to be something that is completely defined and independent and focused on things that limit interaction. Instead, it's meant to be focused on interaction, engagement, and collaborative work with the broader community and broader set of stakeholders. And then just the last couple thoughts. What we're trying to do with E4S is create an ecosystem. There are a lot of ecosystems around, but E4S is emerging, and this ecosystem analogy, I think, is very important as we try to do our work. For a little bit of a deeper discussion of what some people at least think about in terms of ecosystems, there's an article written by the level 2 leads of ECP, Lois Kerf-McInnes, myself, Eric Drager, Andrew Siegel, Susan Coughlin, and Katie Antipas for Nature Computational Science, kind of an attempt to give forward-looking notions of what community software ecosystems can be like and why they're important to us. And I'll stop here and stop sharing, and we can move on, and hopefully Todd is here. Good, Todd. So take about 10 minutes if you can, and get started. Okay, we see your slide. Oops.
Oh, can you not hear me?
We could not, just now we can.
Sorry.
Yeah, that's all right.
Where did it go? Try again. Okay, sorry.
All right, here we go.
Okay, so I'm going to give a SPAC update based on, so just to follow on with what Mike said, SPAC is the part of the ecosystem that deals with relationships between packages. And so if you look at the HPC stack, HPC simulations rely on huge numbers of dependency libraries, and it's getting more complex. MFEM is a small package. It's got 31 packages. LBAN is a neural network package, 71 packages, 188 different relationships between them. And then MUMI is a good example of a newer sort of integrated simulation and ML pipeline. The thing has 98 packages and 248 different dependency edges. And there are bigger codes than this out there. So things are getting much more complex as we integrate all of these packages together in one ecosystem. If you look at the assumptions made by most package managers, there's sort of a one-to-one relationship between source code and binaries per platform. Binaries are expected to be very portable. They're not really optimized for the machine, and the tool chain is kind of the same across the ecosystem. And so if you look at HPC and what we're doing under ECP, we're trying to build an ecosystem that violates those assumptions. We want to have software that works on a really wide range of hardware, that runs fast on that hardware, where different code teams can use different packages in different ways. And we want to rely heavily on system packages. We want to rely on things that are not necessarily in the ecosystem, but that come with the machine, and that span multiple languages. And this is probably one of the hardest software integration problems that there is out there. Just the number of variables and the number of ways people deploy HPC software is very different from how I think most industry teams deploy their software. Most industry teams would pick an environment and say, that's our environment, that's where we're going to run. But in HPC, we're on the bleeding edge. We have to bleed, so we run everywhere. If you look at the types of requirements in these ecosystems and why there are sort of cascading failures, this is MUMI again. If you need a new version of one dependency, these relationships can sort of span this whole graph. And so a team needed a new version of Keras, and there was a huge cascading set of requirements that ended up at OpenBLAS. OpenBLAS was actually the system version, and it wasn't compatible with any of the versions that they had. So people spend hours and hours dealing with these types of problems. OS updates underneath the stack cause a lot of problems in HPC as well. So SPAC enables software distribution for HPC. We're trying to put automation around all of this stuff to make it easier for people to manage their relationships between pieces of their software. We make it easy for developers to package the software so that the requirements are well known and a tool can deal with them. And we try to make it easy for users to deploy the software the way that they want according to some specification of their own. And so with SPAC, you can use the syntax like this and say install a package. You can put constraints on that. And those are integrated with the constraints provided by package developers. And then ultimately it's put on a machine and built either from source or, as you'll probably see in this tutorial, from binary build caches. We're trying to accelerate developer workflows that way. SPAC has taken off. It's used on the fastest supercomputers in the world, including the current top three. So Fugaku, Summit, and Sierra. It's going to be used on the ECP machines. It continues to grow. And so SPAC actually it spans outside of E4S. It's over 5,400 software packages now with 780 plus contributors, and the package contribution rate is increasing. This is showing contributions from different organizations over time. In 2020, there was an uptick in the slope of this contribution graph. We had an all-time high in the number of users on our docs site. So this is showing users over time on the documentation site. So we've got 3,700 people per month coming to the SPAC docs, which is pretty cool. And it's critical to ECP. So we're using SPAC to deploy things like E4S, which is ECP's software ecosystem, and beyond. And because of that, if you look at the dependency graph in ECP from the dependencies database, SPAC is the most dependent upon project in ECP. So more than MPI and LLVM. There's a distinction here. We're not the most critically dependent upon project in ECP. If we went away, people could still work, but we save a lot of time and we make managing this ecosystem feasible. And so over here, we're an important dependency. We're not the most critical by a long shot, but we're important. We've introduced a bunch of tools in the past year that make it easier to integrate the ecosystem. We're trying to add testing to what we do. SPAC has been focused on deployment for a while, but we've added this smoke testing capability where you can write your SPAC package with a test method like this, and embed tests for the package directly in it. So if someone deploys your package with SPAC, you can now just say SPAC test that package and ensure that it works on the machine. Tammy Dahlgren is leading an effort to ensure that SPAC smoke tests exist for E4s packages. And so we're collaborating with the E4s team on that. So far, we have a lot of existing tests for different ECP packages. We're working with code teams to integrate those. There's a number of in progress tests, and then there's still a lot missing. So we'd like to work with teams to get tests integrated for these other packages. We're going to, if you make these tests, we're going to run them on the ECP pre-machines and ensure that your package continues to work within E4s. So there's an advantage for you to getting your tests into the ecosystem. We are trying to support platforms, so there's a lot of ongoing work. You can hear more about this in the SPAC BoF that I'll talk about. That's on Thursday. One of the things that we have also done to make builds more robust for ECP is we're expanding CI. So it used to be that we just took package contributions because we could not test all of them. We did not have sufficient automation. Now we've deployed E4s on our GitLab site, and we're using it for continuous integration, where essentially we're going to make E4s a gating factor for SPAC PRs. If someone submits a PR to SPAC and it breaks an E4s build, at least in this testing environment, we're going to hold up the PR and put the burden on the contributors to fix that. And so what we hope is that this will make E4s robust and continue to work. Once we get this the entirety of E4s building in the cloud, we have pipelines at Oregon on the Frank system that Samir deploys, and at Livermore, where we want to run on more exotic platforms. So like I said, we have to support not just the standard cloud containers, but also all the fancy architectures that we care about under ECP. And so once this passes, the contributions can go back into SPAC and the cycle continues. But we want to make E4s the gateway to contributing to SPAC. We've seen an increase in industry contributions from a lot of different companies. It's been really good to see companies under the Frontier and El Capitan contracts start contributing to SPAC. So HPE is starting to contribute. AMD has been contributing for a long time. They've gotten the ROCm packages in SPAC, and we're coordinating with them to ensure that ROCm releases appear in SPAC as new ones come out. Intel and NVIDIA, ARM have all contributed as well. And AWS is working with us on these CI pipelines. And they've started integrating SPAC into some of their product offerings like Parallel Cluster. So there's a lot of SPAC events at the ECP meeting that you can come to if you want to learn more. There's an update on facility pipelines on Wednesday at 4 p.m. There is the SPAC BoF on Thursday, where you can hear more about all of these things in SPAC. And there is a reworked tutorial on Friday that I really highly recommend for app developers, or just really anyone using SPAC to do development. We are reworking the last half of the tutorial this time to target developer workflows, and like the ones that Samir has presented, say, yesterday in the E4s tutorial. Basically, ways to both deploy packages and work on them at the same time, and how to accelerate your development pipeline. So come and see that. I think that'll be of interest to a lot of people. Thanks.
Thanks very much, Todd. Jim, you ready to go? Looks good, Jim. Go for it.
I wanted to talk about the software development kit layer just a little bit that Mike introduced. The definition of a software development kit is a collection of related software products where coordination across package teams will improve usability and practices and foster community growth. Over the past couple of years, we've really found out that each SDK is very unique. There's different needs, and we knew this up front, but math libraries, for example, are very interdependent, and there's a significant dependency chain in them. The development tools SDK has less dependencies among each other, but there's an incredible need to communicate and to work with other teams to adopt those tools. And so each SDK's challenges are very different, but they all have something in common. I want to focus a little bit here on the interoperability piece. It's very important to have common versions of third-party software, for example, and that's not just for things with long dependency chains. Data and Viz, for example, have some common third-party software that they use, and there's a lot of advantage to having a common version of those pieces of third-party software so that you can install tools in a single environment. We're going to look a little bit at our community policies that we've come up with at the E4S level, but there are also SDK level community policies for the Math Libraries SDK, the XSDK, and the Scientific Workflows SDK. Our newest SDK is actually pretty far along in developing their own community policies as well. One of the big advantages to the SDK layer is the community aspect of it, trying to bridge culture between labs and universities, between all of the institutions that are involved, adopt a common vocabulary so that people can share best practices more easily, so that people can understand where others in the community are coming from. And then once you get to that point and you share a common vocabulary, we've got teams looking at things like defining standard interfaces and things of that nature that should really help a lot of our users. I wanted to go over just very briefly a couple of contexts in which you might hear the term SDK. And there are SDK projects, WBS numbers in ECP for all of the areas listed on the left of this slide. But those are projects. Those aren't the SDKs themselves. The SDKs map pretty well to those in some cases, less well in others. For example, the tools and technology and compilers and support SDKs are primarily out of the development tools SDK, but the compilers and support has some PMR representation as well. And so this is important from the perspective of the SDK projects try to help the other projects associated with them, the individual tools, the individual math libraries, and try to help to facilitate communications and such, between those groups and with other groups within ECP, whereas the SDKs themselves work together as a group of developers and adopt common policies, talk about common interfaces, things of that nature. So it's a little bit of an unfortunate terminology confusion sometimes, but just make sure you know what context you're looking at when you're talking about SDKs. I put this in here only because I want to give people a good sense of how interconnected the SDK effort is with a lot of the rest of ECP. SDKs in a lot of cases, and the SDK projects here I'm talking about to some degree also help to facilitate communications between people, between the individual package development teams and the CI team, for example. Maybe try to help the CI testing team that's part of HI design things in a user-friendly way and be early adopters, and then help to spread that around to other people. The SDK team works with the ideas productivity team as well to try to get best practices adopted and try to make process improvement tools known to people within software technologies. And so SDKs is a glue factor for a lot of these things. And certainly one of the most important places is in helping to improve interoperability between a smaller set of projects so that all of that work doesn't have to take place at the E4S level specifically, because we don't want E4S to have 80 different touch points into software technologies for all of the issues that they're trying to deal with. Mike mentioned briefly the E4s Community Policies. These were modeled after the initial XSDK policies, and we adopted an initial set last fall, and there are 9 initial policies. I'm going to try here to, this worked before, to open this link. There we go. Okay, I just wanted to look a little bit at a few of these policies and just talk through them. These policies are not meant to be, really amazing, really out there concepts. These are meant to provide some basis for establishing some minimal software quality standards, and then importantly also to facilitate the conversation to additional improvements going forward, and trying to start those conversations in such a way that we can build a roadmap of ideas for future improvement. So just looking from the top here, just to give people a sense, you have to have a SPAC build. You have to build within SPAC. That's kind of step 0 to be part of the game. Policy 2 is minimal validation testing. You have to have some kind of a smoke test. And exactly how we're going to implement this, I think is evolving a little bit. Right now, we have an E4s validation test suite. We'd like to migrate this to SPAC test, but we need you to have some kind of minimal validation testing. The third policy just simply speaks to the fact that we don't want people just hacking things in to achieve compatibility with these policies. We want things done in a sustainable way, in a way that it's not off on some branch, in a way that a core user of the package outside of ECP would be able to experience that improvement also. The fourth policy just essentially says you need to have documentation. We plan to bulk this policy up in the future if we're able to, but we want to establish a minimal baseline that you need to have some installation and usage documentation. The fifth policy refers mostly to the E4S doc portal, which you'll hear about later, but we want people to participate in that. The sixth policy requires that E4S products have a public repository. People need to be able to get to this. It can't be behind a firewall that people are unable to access your code. If you have new development that you keep behind a firewall for a little while before you deploy it, that's something that can be a workable situation, but in general, the releases of your product need to be available to the user base. And I think I'm just about out of time here. The last items have to do with software dependencies, error handling, and a little bit more about testing. The future revision policies are focusing on areas where we really would like to improve. Portability, being able to choose a subset of tests is also very important, but we'll look at these as time goes forward, and I'll turn it over to the next person in the lineup here.
Thank you, Jim. Thanks for staying on time. Andrew, you're up next.
Great, let me get queued up here. There we go. Can everybody see some slides?
Yep.
All right, and that means you can hear me as well. All right, hi everybody. My name is Andrew Young. I'm going to talk quickly about some of the work we're doing in supercontainers and how it relates to E4S. I'm going to try and go through this rather quickly here. So if you're not familiar with the supercontainers effort, it's a joint DOE multi-lab activity across several different labs. These are the ones mentioned that are directly involved, although we have ties in with pretty much all other labs. The idea here is we want to make sure container runtimes can be scalable, interoperable, and well integrated into our DOE infrastructure. We really want to enable deployments from laptops towards exascale, if at all possible. And I'll talk a little more about this in a second, as well as assisting our applications and facilities to best leverage container runtimes. So this includes really 3 activities, sort of scalable R&D, collaboration, and a training, outreach, and support activity as well. It's important to recognize that we're doing a lot of these activities in the context of interoperability. And we really are looking for portable solutions. And this is where E4s really comes in and shines. We really want to enable that these things can run on our first, they continue to run on our pre-exascale and will be successful on our first exascale systems. So as most people may or may not be familiar with Docker, Docker's great, works awesome on your laptop or the cloud, for instance, but it's not really a good fit for HPC. There's no integration with existing HPC tools, but more importantly, there's some fundamental security issues, as Docker is essentially equivalent to root level access, and that just doesn't fly on shared level resources. Luckily, we have several container runtimes for running our containers. Shifter, Singularity, and Charlie Cloud. The good news here, again, these are the ones that you find. There are many more, but these are the ones that you find at least across the DOE enterprise today. And they all work great. They all do actually work and can run containers in an unprivileged environment. They offer different methods and interfaces for how to do this, of course, but there's some new tools emerging for build as well, and I'll cover that in a second. So this is a quick snapshot of sort of where we see the current landscape shaping up in terms of container deployments across pre-exascale and exascale systems. There's a large variance here that we have to manage, and these runtimes decisions are made by the facilities, and rightfully so. It's our job to help make sure that our applications can fit their containers accordingly on these different platforms. So most of our container runtimes work well with various GPUs. You can see 3 examples with Shifter, Singularity, Shifter, and Charlie Cloud for running on an NVIDIA GPU, for instance, and there's some variation within which GPU you're using. The nice thing is there's been a lot of work in developing E4s images, specifically targeting and providing libraries as necessary for each GPU type, with the newest edition of the One API is now available. There's a link there as well that shows some of the custom E4s images, the base images, the full E4s stack, and how they integrate with the SPAC build cache. So it's a really, really remarkable set of activities. So generally, when we're building these, we're trying to do them in the context of interoperability, like I mentioned. So we're really focused on building OCI, or Open Container Initiative spec container images. And this essentially means we're building Docker files or container files rather than some other more proprietary formats that you may find with things like Singularity. This allows us to use Docker directly on your laptop, for instance, right? You can, or more modern container build tools, which I'll talk about in a second, and then run them using any one of the aforementioned container runtimes at scale. This also allows us to leverage existing container registry services found, across the DOE enterprise. GitLab and the GitLab Container Registry Service. There's several OpenShift and key container registries, as well as Harbor. And if you work in an OCI spec image, you can operate well in this space. So many people ask about containers and performance. Containers are a little different than virtual machines, obviously, but I think many people are familiar with the previous experience of virtual machines introducing some overhead along the way of varying degrees. And I think thus far we're very confident in saying that containers, when used properly, do not introduce any overhead or anything really measurable or significant. We've demonstrated this multiple times. There's been plenty of at-scale experiments run on the Cori supercomputer with Shifter. Our colleagues at LANL wrote a very interesting paper titled HPC Container Runtimes Have Minimal to No Performance Impact, where they studied these 3 aforementioned container runtimes and found on a CTS system at several hundred nodes that they can't observe any significant scalability, any significant performance impacts or overhead other than natural run-to-run variation. And we've scaled a couple of, one ATDM app in particular, Spark, on Astra with Singularity and found near native performance. That being said, containers allow you to have additional portability within your with your software that you didn't really have before. And that comes at potentially a trade-off or with performance, right? So I like to define this performance portability continuum. And I think containers really, while they don't create this issue, they make you have to focus on where you want to be in this continuum. And so a lot of what we've been doing recently is working with code teams, trying to help them make the right decisions on how they can select the right build time optimizations for their target infrastructure, how we can build this into SPAC as well, and create images that could be either highly performant or highly portable or some developer-defined mix between the two. And so one way that we can enable this is really by providing a container build functionality directly on our supercomputing resources, rather than say using Docker on our workstations or laptops. And the way we're doing this recently is through some new Linux kernel features with user namespaces. And you can see an example on the right of how we can basically simulate and enable an unprivileged container build operation by a unprivileged user without root on, say, a login node of a supercomputer using new Linux user namespaces features. And this essentially allows us to simulate or map UID 0 within a container back to a regular user. And that allows them to sudo yum install or install some base level dependencies using a low level package management solution before they then bring in SPAC, for instance. And this can enable some really robust features and be able to target their container builds for a specific architecture. This is a new sort of capability that we've just been releasing. And there's really two container runtimes that we see this being leveraged most readily today in the context of these OCI images. And the first is Podman and its sort of sister runtime, Builda. Podman is CLI equivalent to Docker, but Builda has some advanced features, and it'll use these UID GID mappers. And we've demonstrated this with Astra. There's also a fully unprivileged option with Charlie Cloud, which removes any of that mapping and is a completely unprivileged method. However, it requires injecting what's called fake root into your container image to sort of mask this. Both implementations have been prototyped and working, and we're looking to enable this more recently in terms of a wider workflow within E4S, as well as deploying this capability on multiple different DOE supercomputers. As I mentioned, training is a huge important aspect of this. Containers are a little bit different than what you're used to working with. We've had several successful tutorials at SC over the past several years. We also have a upcoming container tutorial. It's only 90 minutes. It's pretty introductory, but it should be interesting if you're just looking to get your hands dirty initially with containers tomorrow. You'll be able to find that. We're continually modifying and improving content and leveraging some of the efforts that also exist in the wider community. With that, I think I'll turn it back over. Thanks a bunch.
Thank you, Todd. So next, Ryan, if you're all set.
I am all set. Let me share my screen here.
We're amazingly on time. Good job, everyone.
Well, until me, I'll blow that out of the water here. So,
no pressure, no pressure.
All right. So I'm Ryan Adamson. I'm the L3 lead for software deployment at facilities for ECP. Our main objective is really to take the ecosystem, the software ecosystem that, I mean.
Hey Ryan, your slides are in, you just do the swap. You're there in presenter mode.
I think
They're
after
perfect.
a year and a half of being in the pandemic, we would have figured this out by now. But
nope.
Gosh. And so our objective, right, is to take the software ecosystem that's coming out of ECP, make sure it lands, in a tested way at the facilities. And so we have like 4 main components. And today, I think the 2 that are most relevant to this discussion are the software integration and continuous integration pieces. So software integration is really about the building and the testing, and continuous integration is about the automation, using GitLab to automate the building and the testing at the facilities. And so when you step back and you kind of look at ECP holistically, I like to think about it in terms of roles and responsibilities. And sometimes you have the application development teams at the very top. And then all the way down at the bottom, you have the facility systems that we're targeting, the exascale systems, right? And it was really exciting to me when I took over a year ago, this area, year and a half ago, this area, because E4s and SPAC seems to be like the secret sauce to kind of map, the two ends of this stack together. And so we formed something called the testing task force, which is really charged with, inserting ourselves where we were necessary into the stack to understand what the building and the testing needs are of these individual components. And so I think the key thing that I've taken away from E4s is really that it's a complexity reducer. Okay, so at the beginning of ECP, we had we're searching for this complexity reducer. Lots of project teams that want to run CI regression tests on facility hardware. And there were a manner of security issues and policy issues that made it a little bit difficult to see the end goal there. And so instead, we've really leveraged E4s as that complexity reducer. It really gives a good, through the community practices that Jim talked about. The facilities can reach back to ST teams with the documentation portal, and we have guarantees of software maintainability and supportability, and using SPAC as sort of like the tool to do the packaging really helps us build the tools as the teams want them built, right? And so once we sort of organize around these three key features here, it becomes easy to see the end-to-end, the full picture for us at the facilities, right? And so in general, we take packages that are in SPAC, E4s provides a level of assurance, whatever we need there, and then they're automatically built and tested at the facilities. And so at the end of the day, this is what we're driving towards on the facility. So facilities, again, are kind of the very bottom here, ALCF, NERSC, and OLCF. And on the left-hand side, we have the continuous integration efforts that we're pushing forward. And on the right-hand side, we have the software integration efforts that we're pushing forward. And I wanted to spend just a minute on this slide because it really shows the complexity of the entire ecosystem. In the top right-hand, I don't know if you can see my mouse, in the top right-hand, there are a couple different clouds that sort of represent the native repositories of different teams. And we don't want to supplant the CI and the testing that's already happening for these product teams. What we want to do is provide an additional set of capabilities of runners at the facilities with a common CI platform that they can take advantage of. Assuming releases get cut, because of XFL, for instance, or PET-C gets cut because tests pass, then they sort of get rolled up into SPAC as a new recipe for a new version. At that point, the E4s team comes in and they've got E4s CI pipeline set up at each of these facilities where we test the builds, we understand if it's going to work, and they do the prep, right, for a quarterly release. These releases are sort of a year-month format. So 2010, October of 2020 was the release that we've been working on a lot recently. Sort of gets thrown over the wall, right, over to the facilities software integration teams for deployment. And what we do is we then build that particular version of E4s that comes with very opinionated SPAC configurations, variants, versions that the E4s team knows to work. And we start there and we deploy what we think our users will use. And we make that available as modules because that's sort of like the first order of what's expected. But then also, we want to make build cache and SPAC environments available in case teams want to take that and build on top of it, to sort of like incremental update of a particular library. So Shazeb Siddiqui at NERSC has made a lot of progress in the last, 4 or 5 months on this. I think in some sense they were well positioned, NERSC was well positioned to do this building. OLCF and ALCF are sort of still waiting on their early access systems to land. So SPAC will see 2102, E4s 2102 installed there. But Shazeb was able to take E4s 2010 and drive through this process of installing. And so what you see here is the documentation that they have provided on their NERSC documentation webpage. And you see that We have access via modules on Cori. We're testing out build caches nightly for HDF5, and we have documentation for the spec, GitLab pipeline that's set up there. In addition, we want to make sure that we get information back to developers on what's broken and what's not. And so Shazeb has been working on using build tests as sort of an execution engine to run the E4s test suite, to check things and understand what's broken as we upgrade the OS or make changes right to our infrastructure. And then he's also exploring something newer in terms of, like, can we use CI badges, right, to show that this was tested at a facility? How did it work? Did it work well? That kind of thing. On the continuous integration side of things, we're making a lot of progress, I believe. The batch of early access systems that we had in October, we already had deployed site local continuous integration platforms there. And a handful of teams have taken advantage of that. This last quarter, we had 2 new systems come in, Arcticus and Spock, that we're working on. And so we've seen an uptick in people, jump onto these pipelines or these GitLab CI platforms at the facilities. So if you want to take advantage of this, let me know, let our team know. There's some slides at the end with some contact information. But I also want to call out that the SPAC smoke tests and E4s test suite tests that Jim talked about, we've seen a big uptick as well. I mean, a tripling of the number of smoke tests that exist in the last quarter, as well as a tripling of the number of those smoke tests that are targeted at the new hardware, the new architecture. That's really exciting to see. That's what we want to see more of. In addition, we keep track of all of the different systems that ECP users may be accessing, and it's a lot, okay? I mean, Ascent, Tulip, Birch, Spock, the TDS that Frontier will have, Frontier, Theta, Iris, Yarrow, Arcticus. There's so many systems, right, that it's so complex. And if you want to stay tuned for the plenary on Thursday, I'm going to talk about this a little bit there. But I think we've made some really good progress in getting AD and SD projects on these systems, using site local CI. And we have folks to assist where necessary. So I guess I have 2 minutes left here. What I want to say is, this is my humble plea to keep pushing forward in this way. If you are part of an ST or an AD development team, and you're interested in this, and hopefully you should be, hopefully you would want us to test your software on the facility systems. The first step is to get access to the systems, and to jump on Spock when it's available, and to try out Arcticus now that it's available. The second step, Jim was talking about this, is and Todd as well. Please create a SPAC recipe for your package. The most effective SPAC recipes are the ones that have variants for the particular tool chain. So OneAPI or the HIP Rock'em stack. I understand that there are issues, there are bugs, there are features that need to be in place that AMD is working on, and things like that. But if you haven't looked at this and seriously, please, now's the time, because we're turning the corner. We're ready to go when Spock hits. And then finally, we're looking for these smoke tests, either in the E4s test suite, but I think SPAC smoke tests will be the way to go in the future. Please, make those interesting as well, and see if you can utilize the GPU during those smoke tests. And then finally, to let us know how you're doing, if your team needs help or not. We're going to use, there's a new checkbox at the bottom here of this table, if you've seen it before, that says ready for installation. And those are the products that we're going to prioritize installing as part of E4s. So I'll give this slide out to Samir so you guys can refer to it. But here's support information if you're interested and want to get in contact. I'm always available. I'm happy to talk. So I guess with that, I'm done.
Thank you, Ryan. Very good. Well, we're staying right on track. Good job. So our next presenter is Wyatt. Spear is going to talk about Doc Portal. Wyatt, do you have slides to share?
I'm just going to show kind of the Doc Portal and the contents of some of the repos.
Perfect.
All right. So wait, that's not the video that I want. Share screen. There we go.
All right, we can see it.
Okay, great. So this is the Doc Portal, available right now at E4s.io. You see the longer URL up here. And the idea behind the Doc Portal is that for all of the E4s products, we want to aggregate the vital statistics and documentation so that you kind of have a one-stop shop for seeing what E4s provides and for getting the information that you as a project manager, as a facilities guy, or just someone who's interested in this software ecosystem can come and see what's available and how it all works. So for example here, so right now this is 76 total entries, and that's programmatically generated based on a set of YAML documents, which I'll show you in a little bit. But for now, we're just kind of looking at the front-facing final product of the doc portal process. And so we can sort of run through here and see what's provided. Every entry includes the product name, the area, and these are all sortable, so you can see all of your data in Viz at once if that's your primary area of interest. A brief description, and then the latest update up for any of the individual documentation elements. So let's see here. If I want to find one in particular, I can look for Tau and immediately sort down to that. And so within each of these entries, we get a larger description, a link to the homepage, and then document summaries. And so in the case of documents that have a preamble like this, you don't necessarily get a lot of useful information. However, this is adjustable. So in this case for Tau, what I want to do is go in and make it so that we see a larger chunk of the total document, so that we get some useful information. But then, of course, you have a link to the total document, and you can actually see that in the product's own repo. And you can see here we have the latest update for each of these documents that are provided. And so the question you might immediately ask is, where did all this come from? Obviously, for these E4s products, manually keeping this up to date would be an insurmountable task. And I agree. So we automated the thing. So this is the E4s Documenter repository over on GitHub. And what we have here is one subdirectory per project that we've recorded, and we're hoping to keep this pretty much at parity with products that are within or trying to be within E4s. And each one of these contains a YAML document. So again, I'll take you here to show Tau. It's just a little E4s document. There's not a whole lot going on in these default documents that are contained within the repository. So we have the name, we have a list of the documents that are going to be collected. We have the area description, the short description, and then whether or not it is a member product of E4s. And that is contingent, as you heard about a little bit earlier, on total compliance with E4s policies. And so some of these, and because this is the default document, some of these might need to be updated a little bit. So the E4s doc portal aggregation system was designed to be minimal effort for the individual product maintainers, which is why we have a default YAML document for every product that we've included. However, the goal, the objective, is for products and their maintainers to take control of their metadata. So if I go over here to the Tau project, so we have Tau's native repo, you can see there is a hidden .e4s directory. So somebody who's actually downloading Tau isn't necessarily going to see or need to know about this. And that contains, in this case, it's just a copy of the default, but we could change this in our own repo as necessary. And so when the documenter is running, it's going to be able to snag it's going to prioritize the product repo's E4s.yaml. So it's going to be able to come and look at this first, and if it finds this in the native repo, it's going to disregard what's in the central repository. So maintainers can change the names of their files or improve on their description as needed. And so you might ask, we have the the names of the files. We have some basic descriptions, but there's other information that's being provided here. Let's see, which of these could I open up? Yeah, so we have some document summaries. We have like the home page. We have a larger description than what is provided in the little blurb description up here. And so the doc portal has a few other sources that it can scrape for this information. One thing that it can use is the SPAC info command. And there's some additional useful information that's provided in SPAC packages. And so, for example, we can get the home page and the extended description. And currently, we're sort of at a minimal reasonable level for information that we provide. We have access to a bunch of other information that can be extracted from, for example, SPAC info, like SPAC configuration options, if that was something that was of interest to folks that were browsing the portal. We also have access to the repository APIs. And currently we're only using that to get the commit dates for the documents, but that provides a wealth of information that can give us aggregate or product specific statistics. So there's so much to be done with the repo APIs that we haven't looked too closely at what we can do. We're sort of waiting to hear from consumers of the doc portal what would be useful that we can pull out and present in this environment here. So that's sort of been our continuing focus in terms of development is getting people to getting developers, getting product maintainers to start maintaining their own documents. There are a lot of additional options. For example, how much of the individual products should be displayed in the summaries. That they will have control over, that we don't want to fiddle with in the default documents. So there's certainly more that can be done here. The other thing that we're working on is support for representing the policies compliance within the doc portal and within and making that more accessible for people who are evaluating products within E4S more broadly. And so this is the very first public display of this project in progress. You've seen already the community policies that was discussed earlier. This newish repository here contains some YAML-based representation of that same policy document, along with and this may change very shortly in terms of format. But a compliance-based document. And so basically individual products will be able to determine or to describe whether or not their policy compliance is in place or how close to in place it is for these individual policies. And we'll be able to scrape that out as well and use that to present the level of compliance for individual products and show basically how community compliant the E4S ecosystem is as a whole. And so that's just getting underway, but we're looking forward to having more of that to talk about down the line. In particular, what I would like to hear back from folks about is what they would like to see presented in the doc portal, and if there are any questions about how to stop using the default product documentation that's currently in the central repository and start using a product mediated documentation description. So start putting your own little E4s.yaml in your own products repository. That pretty much covers where the project stands right now. The E4S doc portal is currently just updated automatically nightly, so it stays pretty fresh. And the main human-based activity that's required is when a new project enters or an old project leaves E4S, that still has to be manually adjusted, and we're still considering policies and perhaps a procedure for allowing entry and exit through some kind of an automated process. I think that's all I've got, so please let me know if there are any questions.
Thank you, Wyatt. That was very nice. Again, perfectly on time. Our final presenter is Rick Arthur from GE. Rick, are you ready to show content?
Yeah, let me
Great.
that. And okay, everything look all right?
We're seeing you right now, but maybe momentarily your content will appear. Oh,
one
now
more.
it's getting
One more
started.
button.
Yep. Yep. It looks
Okay.
good. Take it away.
Cool. All right. Yeah. Thanks for inviting me. I'm going to go through these slides pretty rapidly, but they'll be available so that you can take notes right from them. So here we go. So straight at the heart of the E4S effort, the ECP pillar has been exemplary in engaging modern software engineering practices and aligning the community that 10 years ago had pretty poor cross-lab visibility. I had compiled up these as I attended SOS, Alishan, Smoky Mountains and such, and it was a real boon to see the consolidation and the effort towards consistency, which are listed in the exemplary column here. It's evident in the documentation, the alignment of purpose, and of course the elegant deployment with SPAC. On the next slide, I'll talk a little more about licensing. Tutorials and webinars throughout the years are great, and seeing passionate people like in the Better Scientific Software and Ideas projects are really lending fuel to the entire effort. Of course, central to the effort is platform portability and interoperability in the ecosystem, and the criticality of those who are going to apply these libraries and packages necessitates there be discipline in the validation and test formalisms. So that progress is also key. And I'll take a little more time on the things that are circled here, but generally industry end users are going to look through a frame of seeking minimally constraining, leverageable, high value assets. Whereas their core competency is the product development and service delivery. Software may be part of that, but the software extensions as such, we don't necessarily want a deep investment in those when that can be packaged as a service, which is why commercial software is the default. But it is also far from serving the needs of very high-end industry that are pushing towards exascale. So there's opportunities here to close the gap with commercial offerings in terms of user experience, the indemnification of perceived IP infringement, and formal on-demand support, or as some of the more bristly managers will say, a throat to choke when things go bad. And then facilitated process to adopt these, which may include accessing some of the leadership computing platforms for integration testing. So with respect to the software licensing, this is a heat map that was generated from our IP legal team a while back, and I got permission to use this to help advise on policy discussions, and it kind of shows perceived risk across different licensing, and the term Apache or better kind of came to be out of this. So for the most part, this appears to be right, but it's actually a worst case if there's not a evident license. You can't just assume that that's public domain. So that's one of the things to look at. I also wanted to encourage another way of thinking about how what we just saw, like with the doc portal, is presented. If you're browsing a store shelf or looking at that E4S catalog, you have to kind of be already familiar with the products, or you have some research ahead of you to try to get at what is going to be valuable for you to spend time on. So an alternative perspective is you level set based on common problems. You see in the display here, I have a headache, I have a blister, etc. And so there are symptoms then, or needs that could be expressed as the entry point into, now let me help you navigate the potential solutions. Even those solutions may be in themselves a full solution, or some kind of a component assembly that I need to go through, or they are just the tools that are now going to rely upon having access to resources, knowledge, and skills to craft that kind of solution. So there's an opportunity in communicating the E4S ecosystem through the lens of an end user community by perhaps altering the perspective this way. Then the rest of this discussion, I want to focus on this idea of having maturity assessments, so that you're not prematurely adopting something that's going to be brittle or subject you to maybe more work than you were ready for, or at least if you're joining in on that, you can assist in building that roadmap. So GE and other businesses, I saw Pete's watching here, Pratt & Whitney, these are highly technical markets. And so we want to employ the software reliably, consistently, powerfully, opportunistically to solve our problems, and thus have high demands for these. Now, there is no shortage of people who have delved deeply into asserting capability levels, but we kind of need to tame these and focus into a concise yet complete listing that is tolerant of precision and overlap, but there's an opportunity here. So how I would try to tell this story is we have a business that looks to a engineering laboratory to advise on solutions and get back to the business. Of course, this is actually conducted by people. So some decision maker poses a question and we communicate back an advisory answer using brains and the tools that we have at hand. Of course, those tools, through the eyes of we, the exascale Illuminati, are now computational methods that replace the archaic physical laboratory infrastructure. So the model that will be conveyed into that computational mechanism will embody the question or the problem, and also the solution driven back to the decision maker. The best use of those assets will obviously harness the ever-advancing computing hardware, so long as the software implementation bears with it the requisite numerical robustness and stabilities to consistently drive those answers. What the engineering community has derived out of this is the concepts of model-based enterprise and digital engineering, which provide potential for tremendous productivity gains, so long as the process of the software engineering and use of the tools is flexible and follows mature practices and can leverage the underlying infrastructure. the models, as we get to greater scalability, we can reduce simplifications and gain predictive fidelity. This gives us answers that we need to go back now to traditional methods of validating and bounding confidence on the results, so that we ultimately end up with a infrastructure for these problem solvers that are employing modeling across these criteria. So we want to assert a model's region of competence, some attributes of the architecture and attributes of the implementation and usability that will support the aims. And ultimately, we end up then with a mature, state-of-the-art way of employing these exascale and modern computational methods for doing engineering problem solving. Here is the summary, and as listed on the link in the bottom, there's a article that I did on this, including another view into these slides.
Very good. Thank you very much, Rick. The remaining time we have open for discussion. Todd Gamblin asked a question in the chat. I'll just read it to you, maybe, Rick, and says, can you talk about what GE views to be risky about Apache? Most companies, at least in Silicon Valley, seem to prefer Apache over MIT because of the patent protections.
Yeah, I can share that screen again. And I wasn't the one who put this together, but you can see on there the columns where Apache is shown as more vulnerable are in the linked and slightly modified version. So perhaps under Apache license, if you modify it and deliver it as an executable, it's considered more restrictive than BSD and MIT.
Okay, thank you. Other questions? You can either type them in chat or just speak up. We have a small enough group. I think we can manage the traffic.
I guess I had another follow-up question.
Yeah, please go for it.
Really a follow-up. Yeah, so your presentation talks about what lots of good things that we should do with the ECP ecosystem. How do you see GE contributing to sustaining that ecosystem? In what way could the companies give back to the ecosystem? Because I mean, I see a lot about how we should make the software more robust and ensure that it can be used by companies, but I think anyone using it has a stake in it too. So what's GE's angle on that?
And there absolutely can be opportunities for that. We have some tools that we have been looking at the feasibility of injecting into open source. There are liability concerns that go along with that, and we have to navigate the gauntlet of lawyers in that regard. But certainly in terms of having our context, industrial context for doing the testing and integrating it into those other products, and then providing the user inputs, testing, and technical engagement there, that's something that we can readily do. I certainly would say that with respect to hardware and software vendors, we have some tremendously technical people that, as we've gone through beta tests and such, they've probably gotten more value out of it than we have just in the feedback that we've been doing. We've been doing hybrid architectures and FPGA CPU accelerated systems since about 2000 in our embedded systems groups. So doing that at the HPC level is something that we're welcoming.
I'll maybe just tag on to what Rick said and say, I'm not sure that kind of stability discussion and the giving back discussion are really comparable. I think they're two different things. The stability discussion is really table stakes, right? If you're talking about something that you're trying to put out in the community and have adopted by industry, you've kind of got to be there to start with. And then, once industry is participating, there's certainly I think there's definitely an interest and a possibility to give back as people are using it, certainly to partner within the legal constraints that Rick mentioned.
Yeah. Along those lines, Rick, you had mentioned indemnification. We some years ago, we were trying to put content out on the web environment and ran into the indemnification issue, and that, at least at the time as it was interpreted legally by our lab, we couldn't take on an indemnification clause. In fact, what we ended up having to do was to work with another company that provided the hosting service that we would have purchased directly. They took on the indemnification risk and just charged us, a lot for it. And so it makes me think maybe we have to look at, other entities as part of this if we're going to have a true, DOE industry collaboration that has all the rigor of the legal risks managed.
Yeah, and I was recently talking with Hal about this as well. I think he's on here too. Is the that Red Hat sort of model of shrink wrapping, what we saw with Scilabs, potentially LSTM, and some of the other things that have come out of the labs kitware even, and there's an opportunity to shift that liability and risk while offering some value. And I think ideally, instead of an exclusive license like that, if some of these things, as we see the maturation of these assets, became available for commercial entities to be a vehicle for that delivery, I would anticipate industry would pick it up more readily, but also that you could still have some competition and contribution back that way.
Yeah. Yep. Very good. Any other comments or questions? We have about 10 minutes.
I had a question for Todd. I don't know if you had a chance to see in the chat. Do you have
Oh,
any
sorry,
updates on
Shazeb, sorry.
SPAC?
Yeah. Go
It was
for
on
it.
SPAC search. Do you have any update on maybe the roadmap of this project? It seems pretty interesting. Maybe still in development.
Wait, oh, are you talking about the SPAC search repo on GitHub?
Yeah, the one that Vanessa has been, I guess, working on.
Oh, yeah. So that's, well, okay. Yeah. So that's a little bit separate from this in that is funded by LDRD. That's a research project. It's designed to search through SPAC packages for source code that meets certain criteria. I mean, it's out there. I think we'll keep working on it. It's meant to find usages of things like DL open in libraries where we want to understand how they're used and how we can extract like ABI information from them. But I mean, you could think of it as a general code search tool, I guess. It's pretty rudimentary at this point. I guess, yeah, we could, if you want to send us a PR to add more options for the search criteria, that would be great.
Yeah, I was wondering if it would kind of help answer some of the questions that we have to keep track of, like, if a SPAC package has like a GPU test, the things that are in that Confluence page. Also maybe like search criteria, like across the package recipe, like tags or.
Yeah, I guess that particular project searches the actual source code of the package. So if you're looking to search criteria on SPAC packages, we can definitely add that to SPAC itself. So like whether a package has a test is something that we can tell you exactly from just looking at the SPAC package rather than grepping through the source. So yeah, we should talk about that. I think that's a good idea.
Yeah, I shared some ideas with Tammy about this. So there's that SPAC, I guess, list -t tag. Maintainers can actually tag the package if they want. So I mean, one nice feature would be we'll have a register tag for like E4s. You could search through that web browser, but like if you install the packages, we can do a SPAC list, filter by tags, and I think SPAC find also does that too. So SPAC find -t E4s.
Yep.
So filter by all the tags and just get E4s as opposed to all the dependent packages to avoid all the noise. And then the second would be having similar things, but on the testing side, so filters on tags.
Yeah.
If attributes could be searched because it's all in this class.
Yeah, definitely. I mean, we already have searching capabilities for the tags, and I think we could certainly add more to SPAC list to let you find more stuff about packages.
Looks very cool project. Yeah, keep an eye on it.
All right, other questions or comments? I might mention a few of the things we are thinking about for E4s going forward. One is you had heard about the community policies and the doc portal, and Wyatt mentioned a little bit about how we're going to build as automated as possible assessment mechanism for whether product satisfies community policies. Part of that is also we're going to stand up an application process for they used to fill out an application that tries to document how you satisfy the policies, and then a review process that goes with that, so that we have human beings, because I think that we want to automate it as much as possible, but not automate it completely. I think we have to have some kind of qualitative checks to make sure that our quality policies are being addressed in an all-encompassing way, not just towards the metrics that can be gamed. And I think that speaks a little bit to what Rick was talking about, maturity models and how to incorporate that. So these policies are kind of coupled with how mature is a product. And so as we go forward, we'll be doing a fair bit of that. We also want to do something in the space of software quality assurance for supply chain, which has been in the news lately, but it's always been a real concern. And trying to build on or adopt some of the models that maybe you have to adapt them a bit, because we have full visibility into the software stack that we build on top of as part of E4s. We can also provide some kind of issue tracking and notification across products and versions that could notify a team, hey, there was this bug found, a scalability bug, right? We're not going to go after simple things that are more pedestrian, but maybe a scaling bug or performance bug, correctness bug at scale, and be able to identify, hey, here's an issue that's been found. There's a patch for it. It's in this version of a library that you depend upon because your SPAC recipe says you do, and then be able to notify people about that kind of thing. So that's somewhere where I think we could have some engagement as a broader community and improve quality. All right, any other comments or questions? We got a few more minutes, but happy to let people go and have a little bit of a break.
I can add to your last comment.
Yeah, please Tom, go for it. Yeah.
Looking at, we have some plans to add scanning to SPAC itself, so that we would submit submitted SHAs to virus total. We also have, and I didn't mention this in my presentation, maybe I should have, but we have a large research project alongside the SPAC project right now to look at ABI compatibility and to make it a core part of how we do dependency resolution, so that we could actually manage binaries better and not have to have as many of the version constraints in SPAC contributed by users. Currently, that's a really big sort of manual overhead, and we'd like to be able to eventually generate that manually or automatically. But it's a big deal.
Yeah.
That's a lot.
Thank you. Yeah, thank you. Yeah. A lot of this stuff, the functionality we want, we don't necessarily want to be the developers of it for E4s, because a lot of it does belong in SPAC. but we want to make sure as a potential client of it that, you know, it's servicing our needs and we can build on it. That's perfect. All right, very good. So unless there are other questions or comments, we can wrap up this session. Next session starts at 2:30 Eastern. Nice set of BoFs and breakouts and a panel. So please, you know, pick your next thing and head to it. And thank you all for the participation in this session. Samir, thank you especially to you for pulling everything together and running the show here for us. We appreciate it very much.
Sure.
And all of the efforts of the speakers. A lot of good work going on. Thank you very much.